In this video we'll look at intersecting lines once again using vector equations, but here where the parameter is time and we want the same parameter for each of the equations. So in a previous example we had these two equations here where t was the same parameter, and we ended up with solutions that were inconsistent. I mean, that result there has no meaning, so what we had to do was change one of the parameters into a different variable. But if t is our time value, what we can do is introduce an extra unknown. So we still have t as the parameter in the equation, but then we introduce t take a, so this particular object along that path there is starting its motion at a different time. So it may be before or after the other object. So in this case, if we were to consider equating the x steps, we'd end up with 2 plus t equals 7 take t, and we'll expand the brackets, plus a. So we end up with minus a plus 2t equals 5. If I equate the y components, I'll get t is equal to 1 plus t take a. Here the t's would cancel out and I'm left with a equals 1, which I can substitute back here, and I'll get 2t equals 5 plus a, which is now 5 plus 1, which gives me 6, divided by the 2 will give me t equals 3. So if I let t equal 3 in the first equation, I'll end up with 2 plus 3. I get the x value of 5 and the y value is t. So I get a point of intersection at 5, 3, which we saw in the previous video was the point of intersection of my lines when I used different parameters for both equations. Now for this equation here, if I were to substitute t equals 3 and a equals 1, that becomes 2, and 7 take 2 gives me the 5. That becomes 2, 1 plus 2 gives me the 3. So I do get a successful point of intersection. Now looking at the situation graphically, I've got my two lines with t in each case. I don't have the second parameter a thrown in there. So I have a starting position when t equals 0 in this equation. I'll be at 2, 1, which is this point here. When t equals 0 in this equation here, I'll get 7, 1, which is this point here. And if those objects were to start moving at the same time, the paths do intersect at this point, but the objects themselves won't intersect. So here are those points. We have the starting position of 2, 0, and this object starting at 7, 1. If I were to increase the value of t, which is the only parameter in this example, you can see that those two objects don't actually intersect. The lines intersect at 5, 3, but the objects don't actually intersect with each other. So what I can do is, if I were to introduce the a parameter, which we see here, at the moment a is equal to 0. Let me reset t back to 0 as well, and if I now make a equal to 1, which means the second object has now moved back. It was at 7, 1. It's now moved back to 8, 0, which means if I were to increase time now, we can see that those two objects will actually intersect at that common point at 5, 3. So the lines intersect, and now the actual objects do intersect at that particular time. So if we look at our image here, so lines intersect,
The objects don't. When I introduce the parameter a and I solve for a, then I will actually have the 2 points, 2 objects, intersecting each other at the point where the lines intersect with each other.